coming to this code branch, and if you do, there will be by default 0 code spaces. If you do a plus mark, first time code space will come. Max in the free version, there will be 2 code spaces. You can choose one of them. See, first one I have taken like 3 days back, which is the main branch. It is saying the main branch. And 1 day back, this is class 3. And I can go back to the same thing. When they create a code space, they give some name so that we can understand. That's it. That would be a very random name.
Okay.
Don't worry about the names.
So they gave us the name. We don't choose the name.
Yeah, we don't choose a name. The name they give randomly. That's the reason. See here, what are the name they give? Friendly space
Okay.
doodle, and after that they give some kind of hash, which you can just ignore. So if I get to this, you can see everything. Why they created like this means now we are just working on individual scripts. Down the line, if you go for a Flask application, so then I can expose this as a web app so that anyone can consume from it. Means if I create a website, instead of I publishing somewhere and so, just I can give this URL so that anyone can access. So that is the beauty of this kind of code spaces and others. Publicly working with everyone. And also daily, if you see, this is called as a README file. When you're writing the code, we write like this, but when you preview, it will show in a very clean way. And coming back, so in the last classes, we have worked on already the, comment operations and IPython and all the other things. Next, going further, we also worked on the arithmetic operations.
Yes.
Arithmetic operations were also done. And part of the arithmetic operations is like some kind of complex operations and absolute operations, which are being left. So now let's focus on that. To work on it, as I told, first we will go to the, I think I gave an assignment. I don't want to touch on the assignment. But next, if I go ahead, type conversions. This is the most important thing for anyone who is working on the types. If you can see ij, if I say j, instead of .py, ipynb, if I give, I told that it will create a Jupyter notebook. And the first thing that you need to do is select the kernel. After that, from here onwards, you go here. First, we want to know the list of data types totally. If you see in total, what are the various data types we have? We have like int, float, all kinds of data types are there, right? So if I can count like this, okay, I have something int, float, complex, boolean, so string, none. These are the basic data types. Still, we are not going to the data structures. That is different. These are the very basic data types. If I define any data type, so you can see its data type. Means if I define some variable, if I create a code object and if I define, we can define and print the value and also the type of the value. If I execute, you can see number is equal to 12, which is of type integer. And if you want a float out of it, means like the basic things, when you are one data type, it will be that data type only. But if you define something like, say 12.34, then it will be a float. But what if you want your integer to be converted to a float? Integer will be integer only. It will not convert. For that, there is some built-in functions. So built-in functions, if I say, there were built-in functions for conversions. Conversions mean first if I say int built-in function. So there are many things like this. The first and foremost is int built-in function. What is the point of int built-in function? What all it can do? Int, if you give like an integer, it can convert to an integer. So if you give like a float, it can convert to an integer. And if you give like a, say, boolean, it can convert in integer. Sir, when I give true, it is giving 1. Yes, of course. True in the backend has a value of 1 in the backend. That's the reason
Yes, sir.
I told true is also a integer family. Similarly, if I say false, I will get like 0. Means similarly, if I go for a none, will it work? It will throw an error, right? So similarly, if I go for like a string, if I take like, string, I give the integer, it's a 12, then it works. If I give like a minus 0.00 something, some number I give, that is also an integer, it doesn't work. Why?
Mhm.
Because it cannot take a floating point value. So int
Okay.
can do any data type. So what basic conversions you have seen? So note what we can say is that int can convert. So int or float. So integer as a string, boolean, right? So others it cannot do. This is what the conclusion we understood.
Yeah.
Similarly, if I go for the next, there is one more thing called as float. To address these kind of problems only, that came to picture. So what is this doing? What it can help us? Let's see. In the case of float can take
Sir,
a,
I have a
yes,
quick question, sir.
yes, please.
If I put any string inside the, let's say, the name, let's say int inside the braces, I put like hello or something like that. It will show us error, right?
Obviously. So that's a good point to ask. If I say like, say the same number, say 2 is there.
Oh, yeah.
It don't know, though you call it as a 2, it don't know what is 2, right? So it
Yeah.
doesn't work. So it's a good question to ask. And if I use the same float, if I give an integer, it will work. And if I give like a float of 12.3, it's like a floating point value, it will work. And if I
Mhm.
take like, the same number as a string, integer, or same number as like a floating point value, or if I take like a negative values also, so 12 point, say, sorry, y12 again, minus, so point so and so, I give a negative value. The same number if I give in quotes also. So for all the values, it's gonna work. Sir, why it worked for all of them? Why you got only one answer? Because as I didn't do a print, it is processing all the values and it gave the last value. But if you want all the values, that's a very simple thing. You can pass a comma separated. You can get every value. So if you want everything, you can place a comma separate all the values. Then it's gonna work. Say I placed a comma. If you have within the braces, you can have multiple lines also, right? As it were. If I do like this, you can notice all in one statement. If I execute now, did you see you got all the values as per the hierarchy? But what I want to try is tell is that even if you have a float or int or anything, it can work. So the beauty of creating this int and so is that like this, we can convert any data type. Apart from this, we also can do one thing. Float of, if I want to say, sometimes if I want to process some number, I want to get the minimum value in the particular logic. Then I want to first make it like a maximum and slowly I want to compare. So in the process, I want to create an infinite value. If you want to create an infinite value, I can do an INF. So if I do like, float of minus INF, it's gonna create like a negative INF. So by string, it mean like we need to give like this. So similarly, will it work for an integer also for creating an ENF? It throws an error. So for integers, it doesn't work. Only for float, it has that capability. So it's not just, conversion. So creation also, creation of infinite value. In which purposes we can have, some cases we need to have, right? So in that case, we can use it. That's the beauty of infinite. So, okay. So after this int and float, the next thing we can see is about, as I told here also, the same thing happens. If you give for the same float, something which it cannot do, you give like 2, then it cannot understand, right? This is an issue. So this is what you need to be aware of. Next, after this int and float, there is one more thing I want to showcase here. Yeah. For the infinity itself, I can also mention like this one. There is another way to showcase the infinity. So the infinity, if I want to do, there is one more thing like this, minus infinity or plus infinity. If I do like this also, it is infinity, or just INF also infinity. And again, you need to give the exact case. When I give small version INF, here capital INF, like that. That's the difference. And also, one more thing is that these can understand this, can understand even this one. If I give something like this, to be frank, this slash and slashes, these are all like, white spaces. Whenever you read a text file or so and so, you get these values. There were some white spaces and others. Even in this case, it can ignore that and read it. So does it mean like if I give instead of slash n, if I say like, slash t or something else, it can read it. But if I say like car or quote or something, then it cannot understand. It can understand only the special characters. Only, so white space characters. So what are the various white space characters? Generally, you'll understand slowly. There was a module also. I can show you that afterwards when you go to strings. Only for white spaces it can understand. Sir, can I do the same thing with the integers also? You give it a try. So if I go for like int of the same thing, so okay, instead of a float, I gonna represent with an int. You see, int also works. They can process any numbers like that. Now you understood about the int and float. So the next thing that I want to tell is about integer representation. So we know int and a float, right? Float means a big thing, but within the integer we can do a lot. Integer can be representation with different notations. Int notations, if I say. Notation means what? Representation. An integer can be represented in different forms. One such thing is like, if you are aware, so there were something like, so decimal, binary, hexadecimal, and octal. These were the various notations. Means they are not a different data type. Within the integer family only, it doesn't work with floats. Only within the integer family, a number can be represented in different ways. How do all we represent a number? For that, what all things we need to do? If you are aware of decimal form, decimal number. So decimal form number, if I just Google, you will understand the format. Any number, so decimal format, and like if I say binary format. Decimal format means what are you see on a daily basis. So binary format in zeros and ones. Any number we try to represent in terms of their binary numbers. Means bits. So decimal numbers means, so the number system will be like this. So base 10 means 0 to 10, 9 characters you have, with that you represent. So whatever we do on a daily basis, it's a decimal number system. Deci means 10, 0 to 9 are there. Similarly, binary means represent with only 2 digits, 0 and 1. So how we can represent with 2 values? Anything to the powers of 1. So that is like, binary. So how it actually works? So there will be something called as, um, binary. So let me write. Okay. There will be something like this. If you want to represent any number in the decimal form, there is a standard way. 8, 4, 2, 1 means like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like that. And if you go further, next byte, so there will be 16. So there will be powers of 2 means like 32 and 64 and like 128. So like that, it will go on from the series. If you can see, these were like powers of 2. 2 to the power of 0 is 1, right? 2 to the power of 1 is 2. 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. So like that, it will go on. So depending upon the number that you are taking, it will take. Let's say I am working on a number called as say 8. I want to represent. So if the numbers are greater than that, it will be 0, 0, 0, 0, and it is exactly 8. So you can say 8 and 0 and 0 like this. What if you want to represent 9 now? If some number is greater than that, it will be zeros, 0, 0, 0, and you got 8, which is less than 9. So represent it. So 9 minus 8 means 1. So 1 is like, can be satisfied here. Similarly, if I go here for like 10, how I can go? If it is greater than 0, greater than 0, greater than 0, greater than 0, so 8 I represent. From 10, if I remove 8, I get a 2 reminder. So 0, 2, 0. Similarly, 11, if I have 0, 0, 0, 0, and 8. So 11 minus 8 means 3. So it is less than 4. So 0. So 2 is 1 and here is 1. Any number you are trying to represent in terms of these numbers, right? So 0, 0, 0, 0, and 8 is 1. So 12 minus 1 is, so still 4 is there. 0, sorry, 4, 0, 0. Let me go for like one big number, say like some 68 I want to represent. How do I represent? First I come here. It is greater than that, 0. 64 is less than that, so I present it. Now 68 means 68 minus 64, still 4 is there. 0, 0, so 0, 1, 0, 0. Hope you understood. This is how you do a typical binary representation. In the same fashion, we can do with hexadecimal also. Hexadecimal means like it's a base 16. Base 16. So base 16 means like you will have values from 0 to 9. At the same time, A to F. So that's the reason it has a bigger number. That's why large numbers, like like memory size and others, they represent in hexadecimal form. So large numbers can be represented in a very short way. Similarly, octal, by the name itself, it is saying that base 8, 8 for octal. So 8, base 8 means like what? You will have values from 0 to 7. Like the different notations are there. These were the most famous. But hope you understood, it is not creating to a new data type. Within the same numbers itself, representing the numbers in different forms. That's what we understood. Now, how do you work on it? So for that, there is a built-in function called as bin. So whatever I wrote here, these are functions only. For converting anything to integer, this is a int. For converting anything to binary, it's a binary form like that we have. So if I can work on first, in terms of the binaries, if I say, yeah, if I take any number and I represent it, uh, bin of, say what we wrote here, 8, right? If I say 8, did you see that it is prepending with a 0b, saying that it is a binary value, and after that you are getting the numbers. How many I got? 4 digits, right? So means till the value is like 1, till there it will come. You see here. So if I go for like same bin of 9, so what are the value that you have processed? The same number you are getting 1001. So you got like this. So this is here also I got like 4 digits. But let me show you the third example, like bin of 68, which I did. Now see how many digits I got. Why here I got these many digits? Why here I got just 4 digits? Means it's not like perfect. So how many digits it has starting from 1? So that's the reason from here it got. So as 1 is still here, you got like this. If you go for a bigger number, you got a bigger thing. But for every number for representing, Did you see you got like this? And if I assign this result to something, say this bin of 68, I assign to result, and I am asking to print the result and the type of result. It's a binary value, means it's a representation, but it is represented like a string. Hope you understood. So it is a binary number, but it is represented like a string. Now, so similarly, now we understood about what is a binary value. From integers, how to convert to binary. But how to convert from binary to back to integer? For that, again, we have this int function. Till now, we know like if you pass a number, it's gonna do. But what if you gonna pass a binary number? So binary number means, can I do something like this? If I do like this, what will happen? It will treat it like that number only. How should you make it to treat like a binary number? Means you should pass like that. Even if you pass the same number, but like string, if I pass, it cannot understand that it like that. So whether you pass like this or like that, in both the cases it will be like this only. And in the third case, I will pass a 0b before that. It should be not O, 0b. Then what it is saying? Hey, I can process these two results, but the third one I cannot process. Means the moment you gave, it is throwing an error. So be carefully understand. It is saying value error. Hey, this integer is of not base 10. Means don't worry, it is not an error. So this int function fast passes till now. There is an option called as base. For that we need to pass what is the base. If I tell base 2, then it will work. Means indirectly, whenever you're working on the top for these both two, you have mentioned that individually. You can pass an optional value called as base 2, base equal to 2, that you have already done. So here also base equal to 2 that you have done. Sorry, these are base 10, right? Sorry, these are base 10. What is saying? Int can't convert non-strings with explicit base. Means if you want to convert an integer, don't mention explicitly. I can do automatically for you. So if I mention that, it is saying int cannot convert a non-string if you explicitly mention. Means you don't mention it if you have an integer, means which is a base 10 directly. Direct numbers don't mention. If you have like a different data type only, mention. So we, in this case, we have like a binary, that's why we mentioned. So any binary number you take it will work. Means to understand this, understand more clearly, I can take like this. So anyhow, if I say bin of 64, that also will give the same thing, right? So now indirectly, if I pass bin, it will get the same thing. Then I am passing to it. You see, any number first is converted to binary and again converting back to integer. So this is like int to binary to again int in one shot. So for us to understand, don't do like this. It makes no sense to do, right? Now we understood about this integer family. So with binary numbers. So the next thing that we have is about hexadecimal values. In the same logic, we can create hexadecimal values and also consume also. How do you get the hexadecimal values? So if I get like 10, for 10, how a hexadecimal number is there? So for every number, like how it works. In Python, there is something called as a for loop. You need not understand how this for loop works at this moment, but just imagine it is designed for creating any numbers in a sequence. If I say some 30, if I get, so for the 30 numbers, it will generate. If I say print of, it will generate 30 numbers. So, or like, just take 20 numbers only. So 20 numbers only. If I generate, I get the 20 numbers. For each of the numbers, individual numbers, right? For you are getting values from 0 to 19 something, you'll get. Fine. For these numbers, I want to get the hexadecimal numbers and binary numbers. If I say bin of I get the binary numbers. You see, for each of the number, you got the binary value. And similarly, for each of the number, if I want to get the hexadecimal value, I can give, see, for each of the number, you got like the numbers and the hexadecimal numbers. So binary numbers will be like this, hexadecimal will be like this. And similarly, if you want the octal also, you can mention that octal of the number. So now in one shot, you can see the three types of representations. So how in integers, so decimal form, and this is binary form, and this is hexadecimal, and this is octal. Octal, see here, 0O, here 0x, like that for every number. You see in binary, we have a big number to represent a 16, right? But in hexadecimal, how many? It's going very big, but fine. Now you see even the difference between these two. For a, so another range, if I say like, I want to generate values from say 20,000, so to say 20,000 only, I will not go very big. So 20,000, some 10. I want some numbers. Big numbers are there, right? So for these big numbers, this is a decimal format. In binary, how many digits are used for storing? In hexadecimal, how many? Very much less, right? Even octal also took more, but hexadecimal, very less. That's the reason whenever you have like memory and others to represent, they represent in hexadecimal notations. Hope you understood. And so how do you convert back to the original things? So, uh, so I told like, like this. And also one more point to mention here is that I mentioned here base 2. In the same fashion, so base 0 also we can mention. For the binaries, we can mention a base 0 also. If you mention base 0, then it will treat like a binary. So in this way also it can go. Either you give base 2 or base 0, both will work for the binary. Now coming to back to hexadecimal, octal, and so on. You know how to create the things. So one more point I mentioned is that for any number, we can ask like how many binary digits it gonna get. Means, so till now we didn't work on the attributes, but this is the first time you are working. Till now all are built-in functions. You do a round of it, right? So function. But for the first time, for the number, you cannot do directly this one. This is very interesting. You write a brace around it and you ask dot bit length. Means this 9, if it is converted to binary format, how many digits it's gonna have? That is the bit length. So it is like binary. If you convert it, this would be the value. How many bits will be there? Excluding the 0b, 4 digits. So whereas for 5 digits are there. So it's a 23. Or if you go for some 68 or something, some other numbers. This is all about it. And in the same lines, if you want to convert to an octal and others also, decimal also I showed you. In octal, I told, right? So this is a built-in function. Whether you give a positive or negative, it's gonna convert. And similarly, if you want to reconvert back from the octal, so there is another built-in function, again int only. For that, we need to pass base 8, octal 8. If you pass base 8, it will work. For binary, you can pass 0 or base 2. For octal, like this. And similarly, hexadecimal. As I told you, hexadecimal, if you want to convert, you can directly do like this. Means hexa from conversion. And if you want to convert back, so we have like this. So hexadecimal to decimal again. So you got the results. Base 16 means you got the answer. So like that it will work. So different formats of the things you have. Next, one interesting thing so is about for the numbers. So they created like one more recent one, some attributes they added. Means this is kind of like a checks. Means any number you give, is it an integer or not? Integer means like if it is 2.0, so like that. So 2, 3, 4, 5, 6, these are integers. If you have a floating point value, right? These are all floating only. It doesn't matter that. Means a rounded off number or not. So is it an integer? No, 1.999 means it's still not 2, right? So that's the reason. So like that, you can do with checks also if needed. And one more interesting thing. So for the int built-in function, which I didn't tell earlier, is that for if you have a strings, we can read, right? I told an integer can read from a strings. At the same time, this integer built-in function can read from a string if it is like a Roman numbers or non-English characters. If you see this is a Telugu character, if I give, it's gonna work. So these are some characters, and it is a representation of the same 42 in Telugu characters. So you got it the number again back. And similarly, so the beauty is like we can get the any of the Telugu photonic like any other languages in Telugu. So these are the characters which are representing the alpha numbers actually. So what we call it as 0, 1, 2, 3, 4, right? For that, this is called a 0, 1, 2, 3, like that. So for that, you got the things. If you give base 16, then it can read it. So how I got these references? There's a table, so you can just walk through it. So you can see different languages. Which are the language you are interested? You can just go there, and it can help you with the symbols correspondingly. It's a very good place to understand the different characters and their ASCII values and others. So like this, we understood. Now the last and most important thing and most powerful is the string operation. So this is called as more powerful because of the uniqueness. Till now, whatever you have worked till now, everything has some advantage, everything has some limitation. But one thing is that anything can be any data type. Any data type can be converted to a string. This is the most important thing. You give any data type, it can convert. Say if I give str of 1, it's an integer. Str of negative values, integer, it works. Str of like floating point value, it will work. Str of negative 0.0 so and so, it will work. So you give like int. For int I showed int, it will work. So float, it will work. So anyhow, we are not interested in the values because the same value will come as a string. If it throws an error, you will see that. Int float you have. So int as string. So that is also a point, right? Int as a string means like string. If you already have a string, so means like a number I have, or like the same thing, like 12.3 some. So this is like a string, or like you have a string of 2, or like you have a string of some Uday or something. So, or like you have a boolean. Boolean means like you have a true, or you have like a false. These are the booleans. Or if I go for the none data type, none. Trust me, what data type you have give, everything can be converted to this. But why I got none? Because that's the last value. That's okay. You can understand, right? String is a powerful thing. We can convert anything to a string, but not vice versa. This is all about it. With this knowledge, can we create a small real world problem? So if I go for the real world problem, say I want to work on, centimeters to feet to centimeters conversion. I want to create a small program for that. Generally, how we write the shebang line, it's not mandatory, but if you write, you need to go. And what is the feet to centimeters conversion? 1 feet is equal to 12 inches, and 1 inch equal to 2.4 centimeters. We were given these two, and we need to do it. How do I do this example? First, I need to write an algorithm, right? It's not mandatory, but if you are a beginner to programming itself, then it will help you. So what is the algorithm steps? If I can count on step 1. So first, what I need to do? So I need to get the feet value in runtime. So from the user, for the given feet, I need to compute the conversion. So in step 2, I need to compute the conversions. And step 3, I can display the results. Step 3, display the results. And within the conversion, you need to understand. First, convert what are the user has given in feet, right? So feet to inches. So then followed by, so inches to centimeters, right? Centimeters conversion we need to do. So how to work on it? If I can start. First, I need to get the feet. So what I can do? Hey, feet is equal to, how to get the in runtime? We can use a built-in function called as input. If I just use input, will it work? If I just need to go to the terminal, I can go to the terminal because it's a Python file. We cannot work immediately. So for that, we need to have a terminal. In the terminal, if you want to work, you need to navigate to this directory where your files are there. If I can take the path, so if I allow it, I can go to the directory. So if I say clear and Python, so what are the program name is? If I give it, it's gonna work for me. So it is running. So it is running, but it didn't complete, but it's waiting. So you know, right? In the input is a built-in function which will take from the user. But for user means for the people to give input in terminal, we need to tell that, hey, give in feet. If I give like this, then user will give. Rather, if you want to make some statement, also we can write in the top. If you say like, how tall are you in feet and inches? The same statement I can give within this also, or I made use of both of them together to do whatever I want. So if you see, if I repeat again, how it's coming. So I was given some feet. Say I was given like, so 5 feet 4 inches, right? Or like 5 feet, I was like 5'9". If I was given 5'9", it will work. I got 5'9". So how do you convert from feet to inches? You see now, we have like feet. So whatever feet was given, first we need to convert to inches. So I say inches is equal to 12 into feet. How much feet was given? Or else, this was a constant. You can mention like 1 feet is equal to. So constants, we can mention here. Say feet or like foot. Foot is equal to, so 12 inches. So 12 into inches you can write. And so assuming that like 12 for us to understand, and like centimeter is equal to 2.54. Sorry, did I mention it wrong? Yes. Okay, so we can come back. I was confused there. So simple here. Yeah, I have like, what are the feet was given that I need to multiply with 12. Then like, so why this is a problem? Because I'm trying to do premature optimization. First try to implement the code, then to optimize it. So inches is equal to 12 into feet. Then what are the things I need to get into? I got inches. Now I need to convert to centimeters. So centimeters is equal to, what are the inches you got? That you need to multiply 2.54, right? 54 into inches. So finally I got some result that I will present it. So I need to give it. So what are the centimeters is there? I need to present it. If I execute now, it will work. If I say like same 5'9", it will throw an error. The reason being, string we cannot multiply with a float. String we can multiply with an integer, but not. But why string came picture? So int built-in function will take anything like a string. If you want to take like a integer, you define it. If you want to take like a float, then you mention like float. So if I execute again, so if I say like 5 9, I get like 179 point so and so centimeters. Yes, this is a formula. It will work. So if you have the formula in different ways, you can mention. So the total feet you want to mention. So I was given like feet is so and so 5 9 or 5 8 something. So I got the answer. So but like if it is something very big, it's very difficult to understand, right? So that's why we need to round off. How to round off? So we can use the same thing. So round is a built-in function. For that, if you pass like 2 digits, 2 or 3, how much you want. So based upon that, it will convert, and you can see. If I say the same 5 9, I get like 174 and so and so. And if I want to mention like centimeters, I can say again centimeters. If I say like 5 9 height, if it will say this much centimeters, right? That's what I understood. This is works. If I say again 6 1, it will say these many centimeters. Now you wrote some code for you to understand. So these were like constants. So earlier we got a confusion because we tried to do a pre-mixture optimization. Now we can write the constant for it. What is the constants? We know. So when you're converting from inch to feet conversion, we have like that. So 1 foot is equal to 12 inches, right? So maybe like to understand, foot to inches. Now this is more clear. Earlier it is a confusion. So foot to inches is 12. You replace it. And similarly, what you want? So inches to centimeters is equal to 2.54. Now it's much more readable. At the same time, it's easy to understand also. You got it. So now you have a constant separately, your main inputs you are taking, and like your conversions, and for the rounding off, and you have a logic. The same thing if I do again 5 9, it will give it. So hope you understood how I wrote a simple program. This is how it works. So similarly, now if I go for the next one, which is about the complex numbers. Complex numbers means like this is a numbers instead of a py file, ipynb. If I do, I don't need this file right now. I will send. I created a new Jupyter notebook to help you understand. In my career till now, I didn't use this complex numbers till now. But if you need somewhere to use, you can make use of it. What's the purpose of this complex numbers is that whenever, okay, 1 2. So complex numbers is equal to real number plus imaginary number. That's a one thing that you need to be aware. In Python, to represent a imaginary value, we have this symbol, which can help us to understand. Okay, yeah. J is a symbol which is used for representing any imaginary value. In some language, they use I, like MATLAB, they use I, or some languages use J for representing imaginary value. Now see how a imaginary value is created, how a complex number is created, I will show. See, if I have number 1 equal to 2, if you ask, it says yes, it's a number. And if I the same number, if I plus 3, if I give, it's an addition and you got the result. And now in the structure, let me show you with a slight difference. Instead of just 3, I will say 3j. The moment I use the character j, it has done like this. Sir, will it work with any other character? No. Only j followed by number followed by j has this particular thing. And with this, we can have like negative values, floating point values also. The moment j is encountered, the point is treated as like a imaginary value. Now, sir, what will happen if I have a 0 followed by j? So 0 has no value. Then will it treat like only real value? No. even 0j is also treated as an imaginary value. So once the imaginary value is found, it will treat the total value as a complex data type. And or individually, if you give a negative value also, negative 0 I give. So 0 has no sign, but still if I give, you can see the answer, how it will be. The sign of the 0 will also be retained. So the point I want to mention here is that if you mention the notation, so imaginary part should be like this. If I mention the same thing in a reverse way, like instead of 4j, if I mention like j4, it will throw an error. And what is the error it is saying? It is thinking that it's a variable, and it is thinking like some variable is defined with that name. And similarly, for the same 4, if I say 4 into j, then also it will throw an error. So it will think like, hey, what is the j? So, or like whereas if you give the same thing, like, if you want 4 into j, 1j if I give, it will work. Or if I do j4 also, it doesn't work. Means every time the syntax, so there should be j followed by anything. So any number followed by j, that will work. And also like, so the 4 into j, why it doesn't work means it is thinking like j is another data type. So this is what the conclusion that I want to mention. So 4 into j, j4, j into 4, these all things doesn't work. Now you understood about what is a complex number and how it is created. What if you want to create a complex number? There is a built-in function called as complex. You can use that built-in function for creating complex numbers like this. If you pass any number, it will create a complex numbers. And so this concept of equivalence. Equivalence means like, so two values are equal or not. That's what I am showing clearly. If two values are equal or not. So if I say like, 4 is equal to 4, as both are numbers, integers only, real values, they are equal. 4 is equal to 4.3? No. And similarly, is 4 equal to 4j? No. Because 4 as an integer means real value is different from 4 as an imaginary value. Fine. Going further. Similarly, one more interesting thing. If I say, this is one of the interview question to ask. Is 3 plus 4j equivalent to 4j plus 3? Yes. The reason being, it's very simple to understand. Whenever we are comparing, apples will compare to apples and oranges to oranges, like that, right? So the real value in both sides is 3 only. Imaginary value in both sides is 4 only. So that's why they both will be equal. At the same time, if you do the reverse of it, means if I do something like this, I have 3 plus 4j, 4 plus 3j. So whenever it is comparing, the real values are not equal. Imaginary values are not equal. So that's the reason they will throw a false. So this is all about complex numbers. And in these complex numbers, if you want to further work on it, there is one more interesting point I want to bring to notice. Now, I want to tell that Python is an object-oriented programming language. This is another thing I want to tell in this class. Python is object-oriented programming language. What is this object-oriented programming language? Why it is called so? So let me give a very example of a object-oriented programming language. Sir, we are not using any classes. Generally, everyone says that object-oriented means there should be classes. But in fact, it doesn't mean that there should be classes to work like an object-oriented. We should think everything like an object. We should treat like that. If we can do that, it's an object-oriented, in fact. So how can we prove that? So for that, like, if I take a very simple example of say, a pen. So one of the objects before us, pen is an object. Like a human being, how we recognize an object, pen individually, because it got a particular shape, particular color, and particular texture. So based upon these things, you understand. Some objects don't even need all those things. Some objects need more details to understand. So, but like in terms of usages also, if you see, there can be varied usages also. And similarly, if I go for the example of a, like a pen, let me take a cell phone. That is also an object. It has a proper color, proper shape. Not everything may have a smell. Means like every object has its own characteristics. And if you guys take the usages, we can do many things, right, with cell phone. So like that, in Python or any language, if someone is treating something as an object oriented, you need to understand very basic thing. Everything should be treated as an object. Means when you're treating anything as an object, every language should possess these three things minimum. It should be stored in a particular address. You should able to get that. So it should be of a particular type, and it should have some value, and it should have some associated attributes, means usages. So some usages also. Usage of that object. So like that we need to have. So if you have something like that, then we can treat it like an object. Sir, how to get these things? If you want, till now we know how to get the value and how to get the address. If you want to just get the value, so you can pass this. And if you want to get the address of it, type is a built-in function. Sorry, data type. And similarly, if you want to get the address location, there is something called as ID. ID is a built-in function to get the address location of any object. So number one is something, it is of a particular type, and it is the address location. Sir, what is this number? It is nothing to do with us. When you are storing in Python, in the RAM, somewhere in the heap space, it will store. This may be different in different places. Every time when you reload, it will change. So it is nothing in your control, but you can be aware. And the last point for any object is in terms of usage. Like pen has some usages, like cell phone has some usages, even your, so this object, which is of type complex, also has some usages. To get that usages, you have a built-in function called as dir. If I give dir, these are all the list of attributes it has. Means these many things we can do. But don't worry, we will not do all of them. There is a reason to say that. Means these underscore things, whatever it is there, we will use that indirectly in other places. For every object, the same thing works. But things which don't have an underscore only, we need to deal right now. Means if you don't have underscore means there are three values. The numbers, dot real, conjugate, these are called as attributes. Now, the most common question that you will get is, sir, what is the difference between an attribute and a function? Function means like a print is a function, type is a function, ID is a function. These are generic enough. Whereas attribute means it is associated only to this object. So if I say here, in this case, I'm saying number one is equal to number one. If I say number one dot real, this is an attribute. Attributes we access with dot attribute, dot character, whereas the functions you do with a overall. So what it does this dot real and dot image does is that it will give the imaginary and real values like a floating point values. Observe dot imaginary will not give a j at the end. It will give a true real values. At the same time, there is one more attribute called as conjugate. Not all attributes are like readable. Some of them are like callable also. So conjugate is one of the attribute. If I use this conjugate attribute, I gonna get this. For any value if you pass, it will give the reverse of it. Its sign. Say I have a number one, right? Number one has something like this. And if I do for this, I get the reverse of it. Means number one has minus 0, right? J. This sign of the imaginary value will change. That's it. Even here also see here, -3, -2 dot conjugate. So the sign of the negative value, imaginary value will change. The same number will come. If I do like this, I'll get. And if I give like, plus right now, the plus value will change. That's it. Same number will come. Instead of the sign of the imaginary will change. That's it. So, and one good interview question with this is that, and also for us to understand the concept of PEMDAS is this one. So earlier I told about this concept of PEMDAS. So to understand that, let me go for a -2 plus 3j. I am defining one more number and I want to define it. See here, there is something here. Number 1 into number 2 dot real. Number 1 into number 2 dot real. Observe very, very carefully. What is this happening here in this case? Observe. Which you have two operators at this level. Asterisk is there, dot is there. Which one happens first? PEMDAS tells only about the parentheses, exponent, multiplication, division like that. But if you go one step ahead, there were many operators you will see down the line. For all the operators, there were attributes. So by default, only math means you have only this. But if you go in real Python, there were a lot of things. Instead of one parenthesis, there are many parentheses, right? Each parenthesis has its own meaning. That's a different story. So after that, before even exponent, there is an attribute. See here, immediately after braces, attribute is the highest priority. After that, all others are coming. So in this case, if I can count on, if we count on this one, where we are, yeah, complex numbers. You see now, so attribute happens first. So the same thing I am depicting here. Whether I do in both the ways, the answer is same. Because like this. But if I do the other way, means first to multiply with a braces. Means whatever you place, braces has the most highest priority, right? Parenthesis. So observe difference. This is one of the most asked interview question to remember. So this is all about the complex numbers to understand. And the last thing which is forgot is about the absolute numbers. If I can create a .py file for it, it's a small thing. Absolute numbers. What is an absolute number? How it actually works? It's very simple. For any number you are working, let's say you're working on a cricket score, or like your per over, what is the rate, hit rate, or like you wanna, so, or like what I want to say, if you want to know the value, negative or positive, whatever can be, you just want to know the value, the real change. So over an hour, some overs they will make more score, some overs less score. So what is the rate that you want to say, negative or positive? You just want rate. In those cases, at different cases, this can be used. It's a very simple operation. If the value is positive, it will give the positive as it is. So if your value is negative, it will give also positive. So how it actually works? It's very simple to understand. If I go to the terminal, I can notice that my shortcuts are not working here. Yeah, if I go back to the terminal, um, Python yum so and so. Means I am where somewhere, right? I need to go to this directory, or like directly file also I can execute Python space so and so. So whether it is positive or negative, you get like, so positive value only. So even if I give floating point results also, the same thing works. Even floating point values also, they are also something like this, right? You got the results. But if I go for like a complex values, then this kind of operation happens. Square root of a square plus b square will happen. So that is how they work. So generally in complex numbers, we don't work. But if you work also, the same thing works. Because Python don't have a square root operation, I am just representing with, there is a built-in function module called as a math. Square root, we don't have an operation. Till now, I gave all kinds of operators, right? But for square root, it's not there. That's the reason we need to use a module called as math to show the difference. Of course, it's not needed, but just I'm telling. Square root of math dot square root of power of it, so and so. So square root of a square plus b square. So that is what happens. If you see, the same thing happens. It's just like a proof that things will work like this. And the last thing to say is about the dev mod. This is another built-in function which we have already touched on it. Dev mod. We already know that there were three operators. Dev mod. Say a function which will return two values at a time. Dev mod function. So means like it will give you both the reminder and quotient and reminder together at one place. So till now we know that. So if I do like a division, like 10 by 2, I will get the true results. So in kernel, I get the true result, right? When I do a ordinary division. But there are other two things. If you want like only the quotient or only reminder, we have like this. For that only there is a built-in function called as devmod to help us. Devmod will give both the results in a one single place. So whether it is perfectly divisible or if it is not perfectly divisible also, it will give like that. When perfectly divisible, reminder will be 0. If not, you will get some reminder. So, but there is one catch that, this div mod doesn't work with the complex numbers. So it cannot support a complex and an integer. That's one thing you need to be aware. But so generally, in which cases I used in daily basis is that whenever I'm processing on any number, if I want to get the last values or something, I generally divide by 10. So individually, I can get each digit. You see here how I'm doing. So each digit I pass, I can get it. So like that, I can make use of this thing. So this is all about the usage of it. Now, going further, there is one more thing which I want to tell is about the help operations. I told till now about the arithmetic operations and everything, right? So before even going to the string operations, I want to tell something else. So close others. Okay. Till now we have worked on some programs. So when in any program, if you see, if it is not an IPv node B, but generally a Python script, you can see every program I am writing this kind of doc string. So I tell that it is a doc string called as documentation string, but I never tell like, what is how to use it, right? How to create your own document or how to work with existing documents like that. But if you want to know, so there is something called as a help. What is this help? How it can help us? Then are like, if I clear the screen, if I go to the terminal, in Python, if I go in the terminal, I can go for the help. Help is a built-in function. If you give, it will give the help for anything. If I give like a help of 12, till now, I told about the object-oriented programming. If I define something like a number 1 is equal to some 12, I can get the value. If you want a number value in the interactive mode, you can give directly. But in a script mode, if you want the value, we need to print. Only then you can see. See, basically how it works. It will have one data type also. The moment you give a value, it will understand the data type. Based upon the data type, it will store. So it is having like one data type. And where it is storing in a particular address location, that also we can understand. Similarly, I told there is a built-in function called as DAR. DAR will give you the usage of this, I told. Usage means what are all attributes are there. But if I go for the help, DAR and help seem nearby, but DAR will just give the things, whereas help will give the entire code, how it was written in the backend. You see, again, they also written in Python classes only, if you can observe carefully. These are all the Python classes only. Means Python backend code is also written in Python for conversions. So earlier we have seen in the this that what are the list of attributes are there, right? In the DIR, Those attributes, what all they are doing in the inside, that documentation you're getting. It's still not completed. You can just click on enter, you continuously get it. But if you found your needed documentation, then you can do a queue, means quit. So nothing is printed here, right? Because it's a very big, huge. That's how they do. In the same fashion, let me take one more number called as number 2. This time I'm taking a floating point value. The same logic works. If I want to print, you understood. And if I ask the type of number 2, it is of a particular type. If I say address location of number 2, that will go some random number which we don't know and control of. And if I go for DIR of this number 2, did you observe the difference? Number 1, so some things may be common in the starting, but the last things if you observe, you will understand. For the integer, we have like bit length, conjugate, reminder, imaginary, like that. So for absolute, sorry, means a floating point value, did you see the things are changed? As a integer ratio, conjugate, from flexible, hexadecimal, like that it is coming. Means these values are slightly different. And if I go to the help of this number 2, you can notice that help. What are the attributes you're seeing? Their individual purpose. If I don't do a queue and continuously press on enters, each thing how it's going, their documentation. As integer ratio, how it is converting. If I give 10.0, it will convert to 10 by 0. So if I give 0.0 like this, 0. Minus 0.425 like this. So like this, it's going to work for you. You see, these are all the attributes are there continuously. Finally, at the end, it is saying n. So if I do a quit, q means it will quit. Lastly, if I say like a name is equal to say Python. So if I say like, so type of name, you understood? It's a type string. And in interactive mode, we can just print it. And if you use a print, so for strings, you will understand uniquely. When I use print to print something anywhere, any string, then the quotes will not come. So only in interactive mode, we don't have a quotes to print. So it means like directly both we can do. But here also, if you see the type, so as I told, type of this name is a string, and also like the ID of this name, if I show you, it is of address location. Similarly, if I say dir of this name, you can see the attributes. These attributes are very different from these attributes, right? So attributes means usage is different for each of the data type. Based upon that, you get the list of attributes. But if you see help, you get the help of that. Only for strings, it's very strange that when you ask a help, you don't get it. That's very unique because for strings, because everything is treated like a string, that is one internal problem. Only for strings, when you ask a help, you need to say help of str. But for the other data types, you can just give directly. You can get all the help. But if I go for like, say some, so value is equal to true. It's a Boolean, right? If I ask a type of it value, it will say it's a Boolean. If I say dir of value, it will work. And if I say help of this value, which is a Boolean, you get it, Boolean results. Similarly, if I go say, value is equal to say none, it will not work. We need to be case sensitive. None, it will work. If I say like, type of value, you get it. And similarly, if I say address of, value, you get it. And similarly, if I say dir of value, as it is a none, you got like this. And if you say help of value also, you're gonna get it. So this is all about it. So now like this, you understood how to make use of the existing help. So this is the various helps that you understood. The same thing I am writing in a small program. So just for you to understand afterwards. So whatever I have discussed till now, just I am writing like this. For a dozen is a number, so float, all these things, how it is working. So how help can help? Help is the only statement without even you can place in a code also and run. Generally, if I come out of this exit code and if I clear the screen, you see any script when you are executing, If there is no print statement, you cannot see in the output. But help is the only command you write anywhere, and you can see output here. So that's the one thing. You don't need a print for a help to do anything. And next, one more thing I want to specify is how to see this internal documentation. For that, there is one more thing called as pydoc. There is something called as pydoc for getting this documentation. Sir, whatever we are seeing right now, it's fine. We are seeing either in script mode or interactive mode. At the same time, there is one more thing to get the same commands in the command line. I will tell you what is that. Means either in interactive mode you have gone, or script mode you gone. But here there is something called as a pydoc. Generally, Python, you two are doing Pythons and you are entering into the shell. Or, so earlier I showed one more example, Python -c, and within that you write what are the Python statements you want. So it will do, I told, right? You got it. -c, commands. Similarly, Python, if I say -h, I will get a list of all the attributes. One such attribute most commonly we use is -m. Means whenever you want to use a Python module for your purpose, we can use it. Python -m. There are many modules like that. Using pip, we can do a install. Similarly, there is something called as pydoc. This module also comes by default. This is mainly used for this purpose. If I say pydoc, and if I say like same string, see what are the help for a string came, everything came here. And similarly, if you want to know the help of an integer, you get it. Similarly, if you want to get the help of a none, you give it. So, and similarly, if you want to get the help of anything like a module also, you can specify. Or leave about anything else. You can ask a help of this pydoc only. How to do with pydoc? You can get entire documentation. So fine. This is all the documentation it gives. It's not just this. We can give any custom thing. Say, if you want to know about math or a tuple, fine, it will give. But if you don't know that, what to use. Say, you want to work on time, but you don't know what module is there for time. So you want to get the help. So if I just give pydoc -k and time means what are all the time related modules are there which are installed in this machine at this moment. So those it will give in this environment. Okay, these are all the various things related to time. Which one do you want? Based upon that, you can take a choice. Similarly, if you same help, if you want in a better way, there is one more option. Clear, if I say there is one more option. -b means the same pydoc will create a ordinary server. Means locally it will create an environment so that I can see it. You see here? So even in local also we can do the same thing. You see it created like me in a visually. Now I can parse everything and browse. If I want to know more about the math module, say, I can just search for a math. Say like if I say math, if I search, what are things which are related to math I can get. So the server is a bit slow, but I can get. So these are all the modules which are installed right now. So URL, math, Python, something else there. Say I just want to see for the arrow or math. Where is the math module? It's a bit slow. Yeah, see here, math module is there. If I click on it, it will expand. As it is like a code space, it is taking more time for me. But if it's a local, it will be much faster. You see, the module, it will show in a graphical way for you. Based upon that, you can decide. Means it is exposing that as a port. One server was up. So, or if you want to expose in a particular port, you can specify it. So after all these things, I think it's a bit slow. I can leave it. So I can stop it. Yeah. You can also give it a try. And the last and most important thing, you can create your own documentation. If you want to create your own documentation, this is the exact way we need to do. So first, I will choose a particular script where I want to do. I will choose like one of the scripts. say like we created on the ration store. This ration store application is there. For that I want to do. So first I need to navigate to this directory. So, and if I say ls, I am somewhere here. I go with like in 02 basics and 01 arithmetic operations. If I do a clear screen, so if I do ls, I have the files. So if I clear Python space d ration store, it will give some value. Now for that, if I want to do with this pydoc, Python -m, so pydoc -w, and you give your file name. Till now when you're executing, you give the entire file name, right? You don't give this .py, that's it. Now it will create a new execution. So everything is created as it is. At the same time, it will create a new file with the same name, .html. You see a new .html file is created. It will be different. So you cannot understand here. If I say like, open with, I need to open with browser actually. I think here I cannot do properly. How to do? I need to open this copy path. Maybe like, can I do like this? Not sure, I guess. If it is a local system, I would have done. So actually it will create the entire documentation. This is entire documentation. If I can view, so maybe like I can add an extension here. So HTML viewer, something. I can ask for some extensions if you want. You can just do and do it. So here it's not working, but generally we can create a documentation like this. Even for our code we can do. But the only thing is that instead of your entire .py file, you should not give. That's it. So this is all you work on the documentation. So existing documentation you work, you can also do. Down the line, I will tell you how to create your own module. At that time, I will give much more details. So when you go with your own custom modules and etc. And tomorrow we will touch on the string modules, how to work with string operations, what are the different operations with that. So as of now, we have covered till now this in.